happened while I was moving things around. Okay, so let's consider the following PDE. Okay, U sub t plus ux equals 0. Okay, where u is a function of u of x and t. Okay, and we'll go over more notation in a little bit. Here I just mean the time derivative of u plus the spatial derivative of u is equal to 0. So this is what's called the transport equation. And I want you to show that u equals f of x minus t is a solution, okay, for any differentiable function f that maps the real numbers to the real numbers. Okay. So I'll give you a minute or two to work through this. Okay, most people had a chance to work through that. Anybody want to chime in with what you did to show that this works?
Just plug it in and simplify.
Okay, exactly. Okay, so yeah, I mean, if you just plug in the derivative with respect to t of f of x minus ct, we get by the chain rule minus f prime of x minus ct, x minus t. And if we differentiate with respect to x, then we get f prime of x minus t. And if we combine these results, then we get that ut plus ux is equal to minus f prime plus f prime equals 0. Okay. Now, looking ahead a bit, okay, I want you to think about how you could make up another PDE that this solves. Okay. Any ideas?
I mean, just add a constant and it will do, right? F of cx minus ct. Well,
F of c?
cx minus ct.
Oh yeah, but I mean, what is make up another? Yeah, so any any function of x minus t that's continuously differentiable will satisfy this. Well, what is there another PDE other than this one up here that I wrote down that has this function as a solution?
UTT minus UXX? Wave
Yes, that'll
equation?
work, yeah. So yeah, so another one that will work is what's called the wave equation, UTT minus UXX equals 0, okay? And I won't go through this because we'll circle back to this later, but you can check that that works, okay? And the reason I bring up this example is that it illustrates a few major points that we're going to encounter in this class. So first of all is the notion of what's called a characteristic. So a characteristic is a function of multiple variables involved in a PDE that can really allow you to project a PDE to a set of ODEs, okay? So one of the main methods in PDEs that we use is to turn them into sets of ODEs, okay? If you've had a PDE course before, you know that when we use Fourier series, the coefficients that you often find are the constituent functions of your separated variables using Fourier series are solutions to ODEs, okay? But the method of characteristics also does that by breaking apart the unknown function and the constituent variables into their own differential equations. So this function here, x minus t, is what's called a characteristic of this formula. And if we were to change variables and write that the characteristic psi equals x minus t is the variable that we want to study in this problem, you can actually collapse the original PDE and get back an ODE that you can then solve for f in this case, okay? There's a systematic way of doing that, and that's kind of the first main method that we're going to use in order to study these things, okay? Another thing that we've left out here is initial conditions, okay? So there's also the effect of initial conditions where f is arbitrary, okay? But it could be specified by an initial condition, okay? U of x0 equals some function, we'll call it u0 of x, okay? So these are important aspects of PDEs that they're going to have multiple solutions